Here is a simulation of a locomotive equipped with 26L brake equipment, the air compressor operating and supplying compressed air to the main reservoirs. At the control stand of the locomotive, the regulating valve is set to 90 psi. This results in the brake pipe supplying 90 psi to the rail cars attached. The automatic brake valve is set by positioning the cutoff pilot valve to freight position, while the MU2A valve is set in the lead position. As we look at the simulation of the first attached railcar, we highlight the 3-position retaining valve as it is set to the normal direct exhaust position. We now see that the emergency reservoir and auxiliary reservoir on the railcar are being supplied with 90 psi from the control valve. This is a brief overview of the air connections associated with the control valve of the railcar. As we see the brake cylinder on the railcar at 0 psi, we understand that the brakes are released. The app includes definitions and explanations of all the equipment and activities related to explaining how the air brake system operates with locomotives and railcars. When the automatic brake valve is moved into the service position, the equalizing reservoir reduces from its set 90 psi, which in turn reduces the 90 psi in the brake pipe, and begins the application of the brakes by forcing air into the brake cylinder. Here we are also able to see the flow of air on the locomotive between the control valve and independent application and release pipe and the actuating pipes only found on locomotives. We now see the 90 psi in the brake pipe flowing from the locomotive to the attached rail cars, supplying the reservoirs on each railcar in the train. Here's a closer view of the air from the brake pipe being supplied to the control air for use on the railcar. As we see the brake system charging and the brakes releasing, we return to the lead locomotive to finish the review. Please contact us for further details.